Okay, so we're gonna start the review now. It shouldn't be that long. The test is not that hard. It's also not long. But what's going to be on the test are a few things. First thing is gonna be differential heating. What is that? What is differential heating?
Heating in different places.
Heating different places. I'm talking about different materials. So two things that heat up at different rates have, because of their densities, are going to heat up at different rates and cool down at different rates. Yeah? I might ask you, why does this happen? Can you shut the door? Thank you. Johan's got it. Thank you, Mr. Vaughn. So based on the density of the objects, they're going to heat up and cool down at different rates. What we've learned is that things that are more, denser are going to heat up faster and cool down faster. So that's the main difference that you need to know is between land and water.
So that's differential heating.
The fact that they heat up at different rates based on how much radiation, if they get the same amount of radiation, sun hits them both equally. Remember the experiment we did with all the different cups and soil and sand and water and nothing? They all got the same amount of radiation. They heated up at different rates. Which one went up way fast?
Land.
Land went up the fastest. Technically, it was just the thermometer just getting beaten down by the heat lamp, which is nothing. We called it the air cup, but it was really just the aluminum thermometer and the glass thermometer. But land, the sand heated up the fastest, then the soil, then the water heated up slowest. Which one cooled down the fastest?
The most dense.
Sure, technically the empty one, that was just a thermometer. But of the actual materials, it was the sand cooled down the fastest. Which one cooled down the slowest?
The water.
The water, okay? That's just how it works. You need to know, based on the same amount of radiation, which one will heat up faster, which one will heat up slower. And which one will cool down faster, which one will cool down slower. The faster it heats up, the faster it cools down. You'll get a graph. You have to tell me which materials are which. You might say mud, sand, sticks, whatever it says. You need to use the graph based on the way it goes up and down, and you'll tell me what's what. Got it? You will know what is is wet sand. Wet sand's got water in it, right? Does a puddle got water in it?
Yeah.
Does a bunch of rocks got water in it?
Yeah.
No. So based on that and what you know about water and land and how they heat up at different rates, it'll make more sense when you see the graph, okay?
We have to explain why.
You might. There's a lot of true falses on here. What? That's what I'm doing right now. There's a lot of true falses. There's some multiple choices. You need to wait. What?
Would mud or sand? Sand is the most.
Sand's going to heat up faster because mud's got a bunch of water in it. And what you know about the potting soil, imagine mixing the potting soil and the water. They heat up the slowest. Potting soil was kind of fast, but not as fast as sand. What if it's wet sand? Wet sand's going to hold on to that heat longer. No.
It'll just want to heat longer, right?
I want you to remember this. Water heats up slower. It cools down slower too. There's going to be a point at which the graphs intersect when whatever is the less dense object is going to actually be hotter than whatever cooled down faster. It'll make more sense when you see the graph. Look at your graph and then you'll understand it more. Answer the questions, you'll understand it more. Can I move on to solar angle?
Yes.
This is the bulk of the test. Solar angle matters because we have a couple minutes. We can definitely do this. Solar angle matters for a few reasons. Remember that picture that I posted on Classroom?
Yeah.
Where there's the concentrated light and then maybe at the higher latitudes, like by the North Pole or something, it looks like a circle that's like an oval that's stretched out. That's the same amount of radiation in that area as in the other. But one has a better solar angle. By better, I mean a higher solar angle. So if the sun's coming down straight above you, here's Earth, right? And here's the sun up here. It's coming down on you. What kind of angle is this?
90.
90. It's a right angle. You're probably at the equator at noon. Yeah? The equator at noon, sun's always directly above you, all year round. Okay? Now, let's say you're in Alaska. is the sun directly above you all the time?
No, it's an angle.
No, it's pretty low in the sky. So you on planet Earth like this, looking at the sun over there, it's like an angle like this because it's always pretty low in the sky. Sometimes it's there for 22 hours a day. Just because you're getting sunlight doesn't mean you're getting super hot. You with me so far? It means that area that's covered by all that radiation is getting lit up, but it's taking up so much more space because of the angle that it's coming in at. It has to hit more area, that concentrated area. If there's more solar radiation in a small spot or a big spot, which one's going to get hotter faster? Small spot. Okay, it's like basically more laser beams in one spot from the sun. What else affects this? Not just how high the sun is in the sky based on your latitude, but the season that you're in. The season that you're in will change because you know how we're tilted? Like this? All right, let's say the sun's over here. Northern hemisphere is in
Winter.
Thank you. Winter. Southern hemisphere is in summer because of the tilt. It doesn't have anything to do with how close it is. Don't think about that at all. It's not about which one's closer. 6 months later, half a revolution later, which side is tilted toward the sun? The northern hemisphere. It's our summer. It's their winter down here. And just to see, you remember when I talked to you about, shut the light off? Remember when I talked to you about the solar angle? If it's coming in straight, basically, sun's coming in straight. Can you guys all see that? It's this small area here. But if I raise this up, it takes up more of the surface area with the same amount of light beams coming out of this flashlight. I didn't tilt it at all. Sun's coming in straight all the time. That's very focused. If I raise it up here, it's not. That's how the solar angle works. The solar angle is made by the curvature of the Earth. That's what makes the angle different. Yeah. Imagine if the Earth was flat like this. Every angle would be 90 degrees all the time, right? Even if it was flat this way, maybe it would be 45 degrees, but it would be 45 degrees all along the Earth. This is why we know the Earth, this is one of the reasons we know the Earth is actually a sphere, because the sunlight doesn't hit the same everywhere. Cool?
Yeah.
That's really it. The main reasons that we know solar angle, the main reasons for the difference in solar angle are going to be the latitude lines, distance away from the equator,
And the curve.
and the seasons. Seasons is a big one too. So where you are on the planet and what time of year it is. Also, do not mix up degrees because you measure degrees in temperature degrees, latitude degrees, and angle degrees. I'm not going to make you do any calculations. Just don't mix up the fact that those are 3 different things.